Welcome to my projectbazaar.com. Now we discuss about the product simultaneous facial feature tracking and facial expression recognition. Now we discuss the abstract for the process. The tracking and recognition of facial activities from images or videos have attracted great attention in computer vision field. Facial activities are characterized by three levels. First one is in the bottom level, facial feature points around each facial components, that is eyebrow, mouth, capture the detailed face shape information. Second, in the middle level, facial action units defined in the facial action coding system represent the contraction of a specific set of facial muscles, that is lid, tightener, eyebrow raiser. Finally, in the top level, 6 photofocal facial expression represent the global facial muscle movement and are commonly used to describe the human emotion states. In contrast to the mainstream approaches, which usually only focus on one or two level of facial activities and track them separately, this paper introduces a undefined probabilistic framework based on the dynamic Bayesian network to simultaneously and coherently represent the facial environment in different levels, their interaction and their observations. Now we discuss the flow diagram for the process. At first, the input image is taken from the dataset folder. After getting the input image from the dataset, the input image is undergoing for the process of pre-processing. The pre-processing is nothing but the filtering. The filtering is the process of removing the noise from the image. After removing the noise from the image, the noise-free image comes out from the pre-processing module. Once the pre-processing is applied, the Gaussian filter is used to reduce the noise from the dataset image. After the pre-processing, the face detection is used. In the face detection step, the background of the image is subtracted and only the facial area remains the same. Now the extracted face is contoured by the contour segmentation and the face is detected. Then after the face is detected from the image, the eye is detection using the eye detection module. After the eye detected from the face, the facial point is plotted in the face. The facial point is nothing but the AMM points plotted in the face. These are plotted in the eye, nose and mouth everywhere. After plotting the facial point, the distance is calculated for the each and every point plotted in the face. Then the Gabor transform is applied for the face image. After applying the Gabor transform, the transformed image comes out from the Gabor transformation and the feature also extracted using the Gabor transform. The feature which was extracted using the Gabor transform is known as the test feature, and the train feature is also considered for the classification. The train feature is nothing but the feature which is extracted for the whole dataset images is known as the train feature. The test feature as well as the train feature combined together for the classification. After the classification result will comes out from the classification process. The classification result is in the form of text form. If the expression is the smile, means the text will be the smile. Now we discuss the initial running procedure for the process. At first, select the main.m file, then right click in that file. Now select the third option, run. Now the initial guide window was opened. In that you can see the several buttons. These are known as the push buttons. Then the result of the push buttons are shown in this area. This area consists of the axis. Then this table is represented as an UI table. Now click the button input. After the clicking the input button, the face dataset images are shown in front of you. Select any one face from the dataset. After selecting the image from the dataset, the selected image is shown in the axis 1 with the title input image. Then click the button face detection. After clicking the button face detection, the detected face is shown in the axis 1 with the title detected face. The contour of the face is shown. Then click the button eye detection. After clicking the button eye detection, the eye is detected from the face and it is shown in the axis 2 with the title detected eye. The eye is detected using the bounding box. Then click the button face points. After clicking the button face point, the face point which is detected is shown in the figure and then the points are plotted in the face regions. Now click the facial feature. After clicking the button facial feature, the Gabor transform is done and the feature which is extracted from the facial points. Then click the button train feature. After clicking the button train feature, the feature which is extracted from the whole dataset, that is the train feature, is shown in the table. Then click the button expression. After clicking the button expression, the new GUI window was opened. In that, click the button classify. The classification result is the shared.